Hello everyone, welcome to my channel Cloud and Data with Koshi. So, in this demo, we are going to perform the hands-on part of our iris dataset that we have to predict the optimum number of clusters and we also represent it visually, right? So, let going to start. And I hope in the previous session I have discussed some kind of context on cluster analysis and what is the k-mean clustering, all kinds of stuff, right? And now we are going to prepare some hands-on part on that IDs dataset, and this is our that agenda of that graduate rational internship program, right? So let's move on that coding part. So I'm not going to create or doing the coding in the local system, obviously, because there are lots of other options also be there that we have to explore these things, we have to know these things. So in this hands-on that I'm going to perform, that is Anaconda Cloud. Okay, so whenever you go and search the Anaconda Cloud, so you can see this is the official website of anaconda.com, and this is the code in cloud, and just click on get started for free. Okay, and there are a couple of options you have to add it, and with that login details you go and you can get this kind of Jupyter notebook, and obviously it is provisioned in that cloud server. I am not going to add anything in my local system. This is a cloud distribution of Anaconda that I already discussed in the first session, that how many kinds and how we're going to install different kind of Python installation process, right? I hope I have discussed these things. And now at the time that we're going to add, we're going to create the hands-on part of this program that I'm using that Anaconda cloud part. Okay, so you just go and type anaconda.com and code in the cloud. So everything you will get, and after a couple of options, then you can get this kind of screen. I hope I can means it's clear to each and everyone, right? So now here you can see plus button, okay, and just click over there. So what is this? This is a launcher. So there are different kind of launcher is present, right? So like Anaconda, Notebook, Console, different kind of launcher they are providing, right? So just you require Notebook. So just here right click or create the notebook, and you can see that notebook is present and is asked that which kernel do you want to add, right? So by default this kernel that I'm going to set, and select your kernel, and untitled.ipynb that you have to may change the name, that internship task 2. Yeah, and okay, the name is changed, and just check that that notebook is working or not. Just write here and just run the cell. Yes, so it is working. Okay, so first we have to import the libraries. So I'm just writing importing all necessary libraries. Okay, and first you have to import numpy as np, we have to import matplotlib dot pyplot as plt to import pandas as pd and the data set, right? So from sklearn import dataset. Import datasets. Sets. So how many types of datasets are there in that sklearn? Sklearn has provide, we can say sklearn has provide different kind of datasets. Okay, so few of them are iris dataset is one of them, that is given to that. I'm just going to add the name, right? So you can understand. So first iris dataset. These all are called the inbuilt dataset of sklearn, right? So you have to import the dataset, and this dataset I am not going to add any CSV file. I am not going to read any HTML file. I am not going to read any JSON file. I am just going to import the datasets from sklearn, and these kind of datasets are available, that I am writing the name like digits dataset. Okay, you can wine dataset. Okay, and you can say the breast cancer dataset, that is also available in the pre-built. This is the pre-built, means when you consume the package, when you created the package, na, that time this dataset is already installed. I repeatedly tell same thing. I am not going to import, I'm not going to read any CSV file of getting the data. So this iris dataset is also be available inside the sklearn library, and we have to import the dataset. Okay, so breast cancer dataset. Also you can find diabetes dataset. Okay, I'm just adding all the points. So this kind of dataset is also available. Okay, Boston housing dataset. And we can say that there are different kind of dataset, right? And to load, I also write this thing, to load these data sets, you can use the, you can say this method, load underscore star, and this is the functions. Okay, from where sklearn dot dataset. So sklearn dot data sets. Okay, like I'm just going to just one example. This all the information that is available, the data information that is available in that sklearn dataset library, right? So as an example, load the iris dataset, right? So iris dataset, we have to load this first, because our we have to, our intensive program is that we have to optimize that clustering techniques, right? So you just write in this way from scalar dot data sets and like input. This is the one of the technique, right? Load iris and just go in this cell so and execute first, and we have to see is there any problem or not. So no, there is no problem, it's working. And also okay, it's also working. So load iris and just iris is equal to, you can see that load iris, okay, and just print or this data set, just copy over there and iris, and you can say that this data is there, right? So iris data set. This is one example, okay. The features, name, everything they had been added over there. And the classes name also be there, sepal length, petal length, file name, everything they have mentioned, right? So in our internship program that I am going to use, so this is one of the method you are going to add your iris data set, okay. Now also one of the method, this is one of the example, and now I'm going to concentrate more about our program. So load the iris dataset, other technique, okay. You can see that iris data CSV or data frame, you can write anything, any name you can add, it's up to you. So I have the data sets, right? And we have to load dot load, and you have to add the iris over it, okay. And iris data frame, yes. So now next is that I have to execute this point, and yeah, it's working. And now I have the data frame iris data df, or df you can write, is equal to, we have to create the data frame, right, like pandas. So now with the help of pandas data frame, we have to structure the iris data set, okay, to create data frame, to create the data frame, because you can see the data is normally over there in array format, right? But in CSV or all the things, we require some kind of data frame object, right? So pandas is obviously there and it can help to me. So pd dot data frame, you can see our data is iris data, and this is just copy, this data is loaded over there, everything is there, right? You can also print, if you don't have belief on me, then you can also type. So what is the data type, how many what's the data type of this frame, right? So you can see it's a bunch, scalar.utils.bunch, okay. So this data set is a util tools of the scalar library, that is the data type, or you can say, right? So pd.data frame, and inside that utils we have the data, okay, dot data. This is one data we have to provide. You all know in the data frame, when you created your own data frame, custom data frame, that you have to supply your data, okay, two arguments. You have to supply your data and you have to supply your column name. So write columns. Two things you have to supply. Columns also be present inside there. In first data we are collecting and we have to add it in the data, and dot you can write feature names. Feature name is there. You can say this is a feature name already there, and this is the column. And in this way you have to create our data frame. Once the data frame is established, then obviously everything is as it is. Like you have to read the CSV, you have to take the head, you have to take the tail, how many columns are there. So this is the same thing we are going to produce. So before that, we have to create the data frame. So how we can create the data frame? With the help of pandas data frame objects. And now take you can press the play this button, or you have to execute the command. Okay. So now execute it. Yeah, I hope there is no error. And just take one cell and iris data frame, and you can see the first 5 rows. So to see the first 5 rows of my data frame, okay, and that is the same head command. By default it produce 5 rows. If you add some arguments, then that will work accordingly. But if you don't provide any numbers inside that head method, then it will provide the first 5 rows. Okay, and just execute it, and you can see with the help of pandas data frame you already created, and this data frame object that will return, right? And how we can understood this is the data frame? Just go and you can write the type. You can write type, and you can say check what is the type of the data, right? Just it, and you can see it's proof that it's a pandas.code.frame.data frame object. So it's a data frame, right? And we can with the help of type, with the help of type, we can see the data frame. You can see that how what type of object, what type of objects is it? Data frame, like data frame string or anything, right? It can prove you that is a type is that data frame type. Okay. So first 5 rows you can get, and columns that same thing. How many columns are there? How many rows and columns? Not only columns, how many rows and columns are there? You can take iris df, you can take and then save, and just you execute. So 150 rows or column, rows and 4 columns are there, right? Now we understood that in this way we can get some kinds of information of the data. And now the 5-point summary, you can also get 5-point summary of this iris data frame. So you understood that whatever the data is there, so you can see our data is coming some kind of array kind of things, right? And this we are not going to understood properly, right? So to make it understandable, what I am going to see, we are going to create the data frame. Okay, and once your data frame is created, then you can, rest of the things are same, right? You can get everything of the data frame, whatever the analysis you are going to do, right? So head means how many rows and columns are present, how many first 5 rows you can take, last 5 rows. You can also take that tail method, right? So 5 point summary, right? You can also write and dot subscribe and sorry, describe or subscribe or describe, and you can see there are mean, mode, median, 25 percentile, 50 percentile, 70 percentile. So this is the statistical records, right? That we are going to add. So we also called it a 5 point summary of the data frame, right? So everything you can get from this data set. You can also last 5 rows, like last 5 rows of the data set of this data frame, that iris.tf.tail, iris.tf.tail. You can execute that, and this is the last 5 rows because 150 rows, right? So here start from the 0 to 0 the index start from the 0, so 149 means 150. So tail is there, and if you specified some number, right? Like I want to see last 2 rows of this data frame. Okay, I want to see last 2 rows. So just write this iris data frame dot tail, and here you can provide the value 2. Okay, and you can provide the value 2 and execute that, and only last 2 records you are going to fetch. Okay, so this is some common techniques, and also check is there any null value, how many null values are present, how many null values are present inside this data set, that I can say iris.tf dot is null and dot sum. So it will tell there is no any null values are present, right? So as of now we understood the basic concept and how can we infer the data, some information, right? Now next step is that our main question is that optimal clustering techniques, right? So questions I am writing: how do you find the optimum, or just increase the font size? Yes. So just let's do this thing. Okay. How I can, I hope that you all can see my screen properly when I increase the zoom, the font setting. So next, there's how do you find the optimum number of clusters for k-mean? Okay, and how does one determine the value of k? So this is the our key take points of the internship, right? So how do you find the optimal number? So optimal number, that you get the elbow method. Okay. So what is the elbow method? That we just understood this concept, the elbow method concept. You understood, right? So we have to find out this thing. So first we have to know the elbow method technique, right? So we can say the elbow method is a technique used in clustering analysis, right? And is to determine the optimal number of clusters. And how do you determine the value of k, the optimal number of cluster? So to find out the optimum number of cluster for k means one of the method is elbow method, right? I am also writing here, so just open my notepad. Uh, yes, so it is there. Right techniques and minute. One thing, na? Here I have to add file notes. Okay. So I'm writing the elbow. Also increase the font. Yeah. Yes. So elbow method is a technique. It's a technique for what? For what? Which is used in clustering analysis. Okay. For what? To determine the optimal number of cluster means k. Cluster number of cluster is denoted by k over here. Okay, for a given data set. Okay, we can also told it involves running a clustering algorithm with different values of k. Okay, k, and plotting the explained variation of distortion, and plotting the explained variation or distortion as a function of the number of clusters. Okay. So the elbow method is what? So elbow of the plot is then used to identify the points. Okay. Also write the elbow of the plot. I also created the plotting, no issue. I plot as is it in the elbow method. Elbow. Okay. Plot. The elbow of the plot is then used to identify the point where adding more clusters does not significantly improve the quality of the clustering. Quality of the cluster. Okay. General steps, we can say general steps of the elbow method. First one is that run the clustering algorithms. Run the clustering algorithm. Okay. Then we can compute a measure of variation. Compute a measure of variation. We can plot the result. Okay. And identify the elbow. Okay. Identify the elbow. And finally, select the optimal number of clusters. Okay. So this some kind of concept of elbow method that I have added. Now I'm going to take from the coding side how we can create these things. So we are here. One thing first is now finding the optimum optimum number of cluster, right? Optimum number of clusters for A means classification clustering. Okay, and take one box or one cell like HDF dot ilock, and first we have to create the x values. Okay, these four plots are there, means four columns and the values. Now I have to import int x Yes, so x value is denoted over here. We can get the x value. And now what we'll do, we have to import the k-means from sklearn dot cluster. You have to import k-means. K-means. Okay. And once it is done, so we have to take one array. So take one array. I'm not take one empty list. That I'm better statement, empty list. Okay, so and for I in range and now I have to create the k-means. K means is equal to k means and n first have to creating the n clusters. I have to edit the parameters n clusters is equal to I number of clusters. Okay, so dynamically it will add I. Then I have to init is equal to a means plus plus and you have to add the iterator. So just a minute is and you have to add the max iteration that is 300 of and in init initialization value that is can take 10 and here random state. I'm not going to set random state is equal to 0. Okay, and k means dot fit. You have to supply the x value and WCSS is your empty list and you have to append that k means dot okay. Just execute this line. Okay, and then you have to plot the graph, right? So plotting the result. So plotting the result on to a line graph. Now what I'll do, lt dot plot and you have to range to supply this value 111 and plt dot obviously you have to plot, then you have to add the data, right? And plot and then you provide the title the elbow method, that you can write plt dot x level and number of clusters that you are adding over here in the x bar, and plt dot y level, that is wcss. wcss, okay, it will be printing over there. So within cluster sum of, within cluster intra clusters, okay, and within clusters the value of sum of square square. So then let's take a look on this plot plt dot show and execute. Now you can see that one elbow kind of things will be created, right, in the method. So number of clusters and is exactly my elbow, right? So if your hand you can stretch and like elbow, and and just I'm writing something over here. Then as a note you can see you can clearly see that why it is called elbow method. The optimum number of clusters is where you can say the elbow occurs. Optimal number of clusters from where the elbow occurs. Okay. So first question is that how can find the optimal number? So we are using the elbow method. Okay. So this is when within cluster sum of squares. So this is called WCSS. Okay. Which does not decrease significantly. Already told these things. Significantly with every iterations. So I'll already show you, right? One example, there is 4 iteration is there, right? You can see. Just go over there. There is iteration 1, iteration 2, iteration 3 and 4 iterations over there, right? You're already familiar with these things. And now we have to choose that how many clusters you can choose. You can see that from this above scenario, we choose the number of clusters, that is 3. Okay. So second question is what? The second questions was the 1 minute. Yes, so how does one determine the value of k, right? So now our k, we can see that 3, if we're going to take the number of cluster 3, so we can applying k means to the data set, we can creating the k means classifier. Yeah. So k means and k means then number of cluster that I have to choose, that is 3, and init is equal to k means plus plus, just break it so everyone can understand statement, and then our max iteration, that will be optimal 300, and in init that can be set, you can say 10, and random state to 0, and k means is equal to, you have to demote the k means value over there, and you have to fit predict. So k means we have to determine, then now we have to predict it. Okay, to predict this value and supply the x, because inside the x our all the data are be there. Just okay, something. The problem is there. 1 minute. And now I think some problem with the type error. Okay, so that should be clusters. And yeah, so k means fit predict is there. And if we print the y came in, so you can get, this is the prediction result. Okay, means the clustering kind of things, that key clustering is there. Now we have to visualize. So we can see that 2, 1 and 0, this kind of formation. So 3 clusters. So three clusters they have created. You can see in the array of 1, 0, and 2, right? And now we have to visualize the clusters. So we can all understand the visualization part also. So now we can visualize the cluster on the first two columns. On the first two columns. Okay. So PLT means plot, that we already import all the things, and the scatter plot. And first you have to add a means is equal to this value. Yes, you have to take this one and just x and same, just copy this one. One and s 100 and c, that is the clustering color. Okay, 100 seed 100 values we are going to add. Okay, so to make the cluster data points we can say, and label, that is iris, because Setosa is there, SETOSA. So label information you can collect from here, right? Simple length, labels, all kind of things are there. Okay. And then what I'll do, just copy this line. I have to make some changes accordingly. Copy and paste. And second values, that is your 1. And that is 1. And that is the red color is there. So now I'm taking the blue and label, that will be your Versi color. Is VERSICOLOUR. Just copy this line also and copy the last line and just paste and go to there, and that is 0, 1, and 2. I told, right? 3 clusters. So 0, 1, and 2, and that will be 2, 1, right? And that will be your green, double in green, double E, any color you can set, and label iris, yeah, GINC, Virginica. Okay, so Setosa, Versicolor, and Virginica, these labels already there, and I have add. And now one more point, that centroid we have to add, right? So plotting the centroid of the clusters. So PLT dot scatter. Okay. K means dot cluster centers, so centroid, center of gravity I told, right? Cluster underscore centers underscore 0, comma, K means cluster underscore centers underscore and add the value over there. And last that I'm going to add is value, that is 100, and C, that will be your YOLO, and the label, that is your centroid. Then CROID centroid, and then you have to add the legend. Yeah, this legend value you have to add. Now let's start the execution part and Control Enter. Some error, y k-means is not defined. Y k-means to define this. Y k-means, I think that type error is there. Yes. Reason. 1 minute. So this value you have to change. Yes. Now I hope attribute error now coming. So cluster centroid. Means cluster centroid. What could this I hope that this value k-means object has no attributes cluster centered cluster, that I have to check 1 minute. K-means cluster spelling, I think. Yes, centers, right. I hope now it is execute. Yes. Now you can see that centroid values and all the labels are coming, right? So this is the grouping and the inter statement, inter cluster that has been established, right? So I hope you can understand. This is the plotting a centroid and center value that is declaring and denoted with that label centroid, right? This is centroid, and each centroid you can see this is one centroid and some cluster are formed. This is a centroid, some cluster are formed. This is the centroid, some cluster are formed, right? So you all already told that. So first centroid are calculated and remaining object that similar to the centroid, that value that will be common creating the clusters. So I hope that you all understand. And so this is that concept of k-mean clustering, and the notebook and code is very easy. I already taken all the things that in cluster, the three cluster I have taken, and maximum iterator is 300, and initial that from the 10 the value will be calculating that initial value, and here random state I am not going to take anything, it's 0. And then we have the scatter plot. We have to take in the three scatter plot and three uh, cluster, that red, blue, and green, three labels we have created. And also because three labels you have to create it, and also you have to create the centroid. All both of them, then it will plot the graphs. It will creating the graphs. Okay. So I hope that the data point, the data, whatever is given in the internship, that we also covered. And one more point, that is, if we have to calculating the methods, right, and how we can do that, like I also take the different approach, load iris dataset, and then also iris is equal to load iris. Yes, so yeah, and data, that is one of the other techniques, right? I'm going to see what is the difference will come. So iris dot data, and that is my target. Iris dot target. Okay, all 3 points are calculated. Now we can see apply k means, apply k means clustering, and assuming the optimal k is known. Assuming that optimal k is known. Assume is that right? So k is equal to 3, and k means is equal to k means, because already same techniques, but some things change over there. So in cluster is equal to k, or you can add 3, and random state is equal to 42. Okay, and k means dot fit, you have to add your data. Let's take a look. Okay, so K means cluster. This is created with that method in cluster 3 with the help of 3 cluster, and random state the data for is 42. This is not data, the random state variable. And what I will do now? To know the cluster level, so labels that we might getting information from the K means dot labels. Okay. So labels we also got, and if we print this value, then we can see the labels value is 102. So 3 clusters, same as of now, same. You have to take the different approach, different techniques, but it's coming, right? And visualize the result. Now we can visualize the result using PCA for dimensional reduction. Using PCA or dimension reduction. Okay. And that PCA you can form this value and n underscore names, that is 2, and our data underscore PCA value, that is PCA dot fit, then PCA dot fit, that is data. Okay, not one minute. PC modifying. To input first, to input the PCA. 1 minute, 1 minute. Yeah, you have to import sklearn. This is one technique. Sklearn dot t composition import PCA. Okay. Yes. Sorry, it's wrong. Yeah. There are no model is present. 1 minute. Is present in this. Yes. Yes. Now it's working. So PCA is there. We have to import the PCA, and here. Yeah, so that will be fit transform. And now so data PCA is print data PCA in the next cell to the data PCA. This is the data PCA. So we also taken it. Yeah, so next problem, that is we have to plot the value for the graph, that we may think ELT dot figure and fig size, that will be, this is the templating of your what I can say, you have created one chart, right? So chart has some kind of uh, is one area is there, right? So this area is called a fixed edge. So you have to create, you have to mention the fixed edge. Okay. And subplot, we have to divide it into three plots. The PLT dot subplot 1, 2, 1. And now we have to add PLT dot scatter. You have to add the scatter plot that is coming from data underscore PCA, and we take the first of the rows and then 0. The data you have to supply, na? So data underscore PCA, that is there, and 1, and we have to add the C, that is your target value that you already calculated in previous cell, and C map, that is your and H color is equal to K and S is equal to, and now PLT dot title, you can say ground truth cluster, and just now plot the data points. Plot the graph, not plot the original data points. Original data points with color coded, with color coded ground level, right? Ground truth levels. Truth levels. Okay. And now we have to plot the data points with k-means. Just make the comment, plot the data points with color coded k-means clustering levels. Clustering levels. Okay. And PLT dot subplot, that we can take, and PLT dot scatter is value. I'm going to add data underscore PCA, that is 0. Data underscore PCA is 1, and C map PIR is this, and H color. Let me finish and complete. That is K. H is equal to LT dot scatter, and here K means dot cluster centered underscore centers underscore. I just want to see is there any difference or not. Now centroid value and same thing, just copy this line and paste and you have to add this value 1 c is equal to rate comma marker. You have to specify the label marker and age is equal to 200 and your label is equal to cluster centers. Now I hope everything is ready. Where the title and k means clustering, that is k means is clustering technique. And now you have to showcase your product. I hope that it's done. Yeah. Some spelling. F-I-G-U-R-E, F-I-G-U-R-E. Sorry, some kind of mistake. Yes, so you can see. So this is the ground truth clusters, okay, and the original data points, and then we have to provide the k-means. So you can understand the optimization level, right? So this is the original data points, and then we have to make it. Have to make some zoom. Yes. So you have to create the centroid and then you have to create the data points, right? So cluster techniques. So these two differentiation I have to show to you. So first approach is different. Here I have taken the centroid and I have to use all the clustering methods. And then with the first every group set group of data points, they have created one cluster, okay, and then remaining cluster they will associate it with it, okay. This is one thing, and this is the two techniques I have used. So two set of differentiation I have to show that if my data points with the original data set, right, here you can go and see what the like data PC and then this value, and whenever we creating this value, so there is two different two differentiation data points and clustering techniques that I have shown you. And I hope that we can understand something on that k-means clusterings with the help of coding also in the Python. And if you like, so and I hope that I have done these tasks 2 of my internship program. And if you have any questions, please let me know in the comment box so we can address this concern, and subscribe my channel so we can learn and grow together. And obviously it will boost some kind of confidence in me that we all are learning. And in this way, thank you. We are just completing this session, and I added all that code, all the points that is my your GitHub profile, so you can check and download from there. Thank you everyone for joining the session. Thanks.